Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afisha bin Fazila, and I am the representative from Group 4, and we will be presenting on Lab 2, Flow over Immersed Body and Boundary Layer Theory. This will be the list of our group member, including me, Muhammad Afishraf. Then we have Zikri Hilmi, Abdul Rahman, Ahmed Aman, and lastly Daniel Shafiq. And I will be presenting on Chapter 1. As for the introduction, the boundary layers flow are the flow of water between two layers of external flow through streamlined bodies at high Reynolds number, which have viscous of shear and no slip effect close to the body surface, and each wake up but are almost invisible further from the body. Where a fluid surrounds an object, the currents are referred to as external flow, and the fluid force is also known as lift and drag. As for the background of this lab, the flow of fluid over an immersed body is called an external flow. There is a qualitative explanation for the behavior of flows over bodies. Basically, the analytic solution to flow field are limited to only a few sample geometries. The external flow are characterized by two regions in the flow field, which are the viscous boundary layer near the solid surface of the body and the inviscid free stream. When the flow near to the body, the boundary layer can separate for flow past some immersed body and creating a pressure gradient that can cause the reversal region. The important thing to be analyzed, external flow is the locating point of the separation because the location will have significant impact on the pressure distribution and on the corresponding force acting on the body. This figure is showing us the concept of lift and drag force. As for the background, we continue from before. The normal stress is pressure and tangential stress is shear, which is the symbol tau. On an aerofoil, there are two. Part of the pressure and part of the shear become lift force, and the second one, part of the pressure and part of the shear become the drag force. This show us the formula on the drag and the lift force. As for the problem statement for our project lab, is to evaluate the flow patterns over the immersed body and the boundary layer theory. The objective will be divided into three. First, to identify the fluid flow pattern on different angle of symmetry aerofoil at a different angle of attack. Second, to determine the velocity distribution for flat plate. Lastly, to determine the boundary layer thickness of a flat plate subjected to longitudinal flow for rough and smooth surfaces. Lastly from me, the scope for this lab is to show the shape of the immersed body, the angle of the immersed body relative to the wind direction, and the wind speed all influence the speed of flowing fluid. By reason of boundary layer on the plate is normally caused by factors such as speed of the flowing fluid. That will be all from me. I will pass on to our next member.
And now I will talk about my part, which is the theory. So the theory is the flow in a boundary layer can be laminar or turbulent. The effect of heat exchange, body force, and flow velocity structure are all factors considered which may transition from one boundary layer to another. Just as the flow in the tube, there is no single Reynolds number at which the transition from laminar to turbulent flow occurs in boundary layer. In case of norm and flat surface, boundary layer will be formed. Here we can see the figure shows pressure distribution on top and then the shear stress distribution at the bottom. So in a single flow, the flow is either laminar or turbulent. Relevant difference. Then the ability in identifying the flow basic is the most fundamental part in understanding particle flow. Lastly, the Reynolds number, which expresses the ratio of inertia to viscous force set of fluid.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Rahman bin Bedu. Matrix number MA19293. In this video, I will discuss about Chapter 3, Method and Procedure. For the experiment 1, this is their setup. The airflow bench consists of 15 main components, and I list in the slide as you can see the main components. Okay, move to the procedure. For the experiment 1, as you can see in this picture, this is for 0 angle of attack. Second one is 30 angle of attack, and the last one is 45 angle of attack. Okay, for the procedure, first the aerofoil model is then attached and screwed to the airflow bench. Second, we start the experiment with 0° angle of attack. Next, the switch is turned on and the radial fan is allowed to move. Next, the radial fan speed controller is adjusted at an initial speed of 12. Next, the reading are recorded and tabulated. Next, the smoke controller is then pressed to admit smoke into the flow to view the flow of air on the aerofoil. Next, the picture of the flow of the aerofoil is taken. Next, then the radial fan speed controller is then increased by 1 till speed of 19. And the last one, the experiment is repeated from step 5 until step 8 for 30° and 45° angle of attack. Okay, that's all for experiment 1. Let's move to the second experiment. As you can see in this slide, this is the experiment setup for experiment number 2, flow over flat plate. As you can see, this is the sample for plate. We have two different surfaces for round surface and surface. Okay, for experiment procedure, first the smooth surface plate is inserted into the airflow bench. Second, the first distance is taken as 0 and the following distance taken. The pitted tube is connected to the vernier caliper. Number 4, the pitted tube is first touched to the surface of the flat plate as the first data. Number 5, the radial fan is then turned on and any data are recorded and tabulated. Number 6, the distance of the plate is taken from 0 mm increased by 20 mm to 140 mm, while the pitted tube distance from the surface of the flat plate is taken from 4 mm increased by 4 mm to 32 mm. And for the last one, the experiment is repeated from step 5 until step 7 for the rod surface. That's all for me. Thank you very much. Assalamualaikum.
My name is Muhammad Zikri Hilmi bin Muhammad Daud. Number ID MA18143. I will present chapter 4 for experiment 1. Okay, experiment 1. Flow pattern of symmetry aerofoil at different angle of attack. Okay, data collection during the lab season. Area of aerofoil 0.15 meter times 0.042 meter equal to 0.063 meter square. Okay, initial head is 137 millimeters. Okay, this is a table. Table 4.1 collected result during lab season for 0° of attack angle, and next is table 4.2 collected result during lab season for 30° of attack angle. Okay, this is table for 4.3 collected result during lap season for 45 degree of attack angle. Okay, the data calculate based on this equation. Drag force over dynamic head times the frontal area equal to FD per 1/2 density U square A, where the CD is 0.59, A naught is 0 meter per square, A 30 degree is 0.00315 meter per square, A 45 degree is 0.004454 meter per square, and the CL is lift force over dynamic head times the flame form area equal to the FL over uh, half density U per square time area, where the CL is 0.84 and area is 0.0063 meter per square. Okay, from that calculate for the equation, we can get the table 4.4, calculate drag force and lift force for 0 degree, and next is table 4.5, calculate drag force and lift force for 30 degree, and table 4.9, calculate drag force and lift force for 45 degree, and lastly drag force and lift force at fan speed 16. Okay, for 0 degree, the lift force at 16 fan speed is 0.48951. Okay, for the 30 degree, drag force is 0.1681945, and for lift force is 0.478926, and lastly for the 45 degree is 0.233879954, and lastly for the lift force is 0.470988.
Assalamualaikum warahmatullahi wabarakatuh. My name is Daniel Shafiq bin Muhammad Rashid, and I will continue the presentation with result and discussion. So for the experiment 1, we are interested to investigate the flow pattern of symmetric aerofoil at different angle of attack. So the first question of the result is plot drag and lift forces at various angle of attack for different speeds. So for the given formula here is drag coefficient, and from this formula we can get drag force. Same goes to the drag lift coefficient, and we can get the lift force. Since the given data is since the given data is fan speed and head, so we can calculate the drag force and lift force for various angle of attack for 0 degree, 30 degree and 45 degree. So we key in the fan speed and head equation, fan speed and head value in the equation, and then we get the drag force and lift force. So for the 0 degree angle of attack, the drag force is 0 and the lift force is valid, since the highest one is 0.70688482 and the lowest one is 0.09. Next, the graph. So for this one, the drag force against fan speed, the lowest one is the 0 degree of angle of attack, and the highest one is at 45 degree. So for the lift force against fan speed, we can assume that the value for 0, 30 and 45 degree angle of attack is the same. Next, we go to experiment 2, which we are interested to investigate the flow over flat plate. Next, the calculated data we get, and we can calculate the velocity and Reynolds number and the graph. So for experiment 2, They are divided into two types of surface. The first one is smooth surface, and next one is rough surface. So this is the graph for head, velocity, and Reynolds number against boundary layer of thickness. So this is the graph for smooth surface, and this is for the rough surface. Next, the second question is about plot velocity versus distance of plate for smooth and rough surface. So this is the graph. We can conclude that the highest one is when the thickness is equal to 2.175. Next, we go to discussion. The body that creates the smooth surface is at 0 degree angle of attack, and the smooth streamline portray that regular airflow pattern around an item a laminar flow. What happens to wing profile at 30 degree angle compared to the normal is they produce the smoothest stream. The angle of attack must be 0. So the 0 angle of attack produce the smoothest stream. What does streamline portray? Next, experiment 2. Next, we go to the question number 4 of the discussion. What phenomenon caused the orifice flow to disperse from our knowledge? So the mechanism is known as the Venturi effect. So Venturi effect happens when the fluid enters a condition of restricted flow and its velocity approach to local speed of sound. If the fluid is compressed when a fluid system is choked, a further reduction in downstream pressure environment will not result in an increase in velocity. So next, this discussion about the experiment 2, explain about the boundary layer thickness in the boundary layer of pore surface. The thickness of the boundary layer defined when the mean velocity exceeds 99% of free stream. A rough surface has a viscosity impact, and a rough surface has a thicker boundary layer than the smooth one. So the next is what is the distance in the plate before the flow become turbulent? What phenomena could be the reason of this change? The flow begins to become turbulent at 70 mm from x-axis for either the smooth or rough surface. This distance leading to the edge where the flow becomes turbulent, as well as the thickness of boundary layer at that location must be determined. When the flow becomes turbulent, the boundary layer thickness begins to increase, and the value of its thickness can be calculated using the turbulent boundary layer thickness relation. The last one is the differences in terms of result for smooth and rough surface. The smooth surface has less resistance compared to the rough surface, so the velocity that we get is greater. The point at which the manometer stop changing height on rough surface is raised by 30 mm, since the distance of plate in y direction increases. The moment which the manometer stop changing on smooth surface is a few counts later than on graph 1. This is due to reduction in friction, which reduces the resistance to flow speed. The manometer stop changing height during the 7th movement of the pitot tube for 30 mm. I think that's all for my part. Thank you for your time.
lastly, I will talk about the conclusion for this experiment. In conclusion, is that the experiment that we done is performed successfully. This experiment success in determining the boundary layer of thickness of this plate that has been treated. Based on the data we collected, we found out that when the angle is the default will be also increased by the drag force is and then the velocity of that flow will increase because of the total net difference. The velocity for each boundary layer of thickness also decrease and finally the surface velocity is higher or greater than the velocity of water. And that is all for